Good morning, good afternoon, good evening. Hope you are doing well by the time you view this video. This is a physics lesson. As you can all see, the subject is physics, as you can all see there. And the class is Senior 3. And the facilitator is Mr. Mugarura David. You can all see that. This is my phone number. And I do e-learning services. I provide e-learning tutorials that can be accessed on YouTube, on Zoom Cloud meetings, live board, interactive whiteboard, and many others. So that's all about the introduction. Get ready with your concept book where you will be summarizing some important concepts. Okay, we can go to the next slide. So in this tutorial we are looking at linear motion, and of course the word linear motion comes from combines two words, linear and motion. Linear meaning straight line, motion meaning movement. So basically it is the motion in a straight line, the motion of anybody in a straight line, where we shall look at quite many things. But for the start, we are going to look at the terms that we use. We shall first look at the terms that we use. The first one is distance. We must look at distance as the length between two fixed points. So it is basically the length between two fixed points. If I have a point here, and I have a point there, and I want to determine how far they are apart, I have to measure that length between them, between these 2 points, 1 and 2. That distance is actually, that length between the 2 points is what we call distance. So it is something that is so important, so much important in our physics lessons, and specifically in motion. We shall be using it quite often. The second terminology that moves alongside distance is what we call displacement, and this is the distance covered in a specific direction, or in a specified direction, or in a particular direction. You can use particular. It is the distance covered in a particular direction or specific direction. So while distance is a scalar quantity, displacement is a vector quantity, and it is measured in meters. Are we fine? Okay. Then we move to speed. Speed is the rate of change of distance. You can always attach the word with time, no problem. I've put it there, but you can as well put a full stop there at the end of distance. So speed is basically, we know from primary that speed is equal to distance divided by time. That's why we are defining it as the rate of change of distance. It is very important, and mark all those keywords that I tried to highlight. And yeah, we can as well define it as the distance covered by an object per unit time. Yes, no problem with that. It has no problem. We can as well define it in that uh, in this way. Okay, I think we are done with our second slide of the tutorial. We can go to the third slide. What is important to note as well is that speed is a scalar quantity, so let's note that, and this unit is meters per second. Where is the meters per second coming from? We are saying distance. Speed is distance divided by time. The unit of distance is meters, the unit of time is seconds. So you get m per second, meter per second, and that's how it is coming about. Let us note the following. One, average speed is total distance divided by total time taken. Total distance covered divided by total time taken. That is how we get average speed. Yes, there's when they can ask you to get the average speed. So in such a scenario, all you have to do is to get the total distance that has been covered, and you divide that total distance by the total time. We shall look at those examples in the next slides. Okay, so let's go to another note. Another note is uniform. Another term actually is the uniform speed. This should be another term. Uniform speed. So uniform speed, the word uniform in motion or in physics, or actually in as used in English, the word uniform means constant, something that does not change, steady, something that does not change. Like students, we normally put on uniform for recognition, for identification. However, those uniform are normally the same throughout a given period of study. For instance, you can be in senior 1, you have your particular uniform, senior 2. So this is something to do, it deals with the word, it deals with something that does not change. So on top of the definition of speed, you are going to attach the word constant. This is very important here. This word constant is very important on top of the definition of speed. That word constant is very, very important. So we define it as a constant rate of change of distance with time. You can add with time, or you can stop there. Okay, we have looked at speed. What is important is speed has, of course, begins with the letter S, and it is a scalar quantity, S for S. Now we are going to something that we call velocity. This velocity is something that is not very much different from speed. What is important for us to note under velocity is that whereas speed deals with displacement, velocity deals with, whereas speed deals with distance, velocity deals with displacement. So where there was the word distance for speed, we are replacing it with displacement. Velocity is the rate of change of displacement with time. As simple as that. Velocity is a vector quantity. Of course, I have already talked about it, that speed is a scalar quantity, then velocity is a vector quantity, but it has the same unit as speed. In fact, these words can be used interchangeably. You only must note that speed is scalar, only magnitude, while velocity is vector, has got both magnitude and direction. Are we fine up to this point? Is everything fine up to this point? I suppose that we are moving on and still following. Okay, we can go to the next slide. So average velocity at the same time, like we did look at average speed. average velocity is total displacement divided by total time. Remember, for average, the average speed was total distance, because for speed we look at distance, divided by total time taken. So we must also look at that and note it such that we can get the difference. So here we are looking at uniform velocity. I now know that you can define this, given the fact that you have already looked at what how we defined uniform speed. I know you can now go ahead and define a uniform velocity. So uniform velocity is a constant. Still, the word constant is important. Constant rate, constant rate of change of displacement with time. Okay. Examples. Number 1. A car covers 72 kilometers in 2 hours. Find its speed in meters per second. So the distance here is 72 kilometers. The time is 2 hours. They want speed. Of course, we know speed is distance divided by time, which is 72 kilometers divided by 2 hours. Now, this gives you 36. When you divide 72 by 2, you get 36. So 36, yes, we get 36. After getting 36, we now move ahead. This gives you 36, I think. That gives us 36. So our speed is equal to 36 kilometer per hour. But they want the speed in meters per second. I hope you can all see that very well. So how do we convert our speed from 36 kilometers per hour to meters per second? You need to know that in 1 kilometer we have 1000 meters, and in 1 hour we have 3600 seconds. So it is something very easy. It's something very easy. So this gives us 36 times 1000, because we are converting kilometer to meter. This kilometer is, we must convert it to meter first, then per hour. So we are dividing by, in 1 hour there are 3600 seconds. This is meters, this is seconds. So 36 goes with 36, 2 zeros are cancelling with the 2 zeros, and we remain with 10. So the answer is 10 meters per second. As simple as that. And you arrange your work for marking. So these are the important steps. We got it in kilometers per hour. We converted it to meters per second up to that point. So this is our speed in meters per second. You can as well just do it one step and you get all your marks. It is all fine. So that is what we have looked at. Let's go to the next slide. Question 2 is there. A train covers 360 kilometers in 4 hours. Find its speed in kilometer per hour. So it's just similar to what we have done. Speed is distance over time. Speed is distance over time, and you substitute the distance. It's 360 kilometers. This is in kilometers. and this is in hours, so it is 90 kilometers per hour, which is the first part of the question. The first part of the question is here, then second part of the question is there. So second part of the question is asking us to get in meters per second. So we are converting 90 kilometers per hour to meters per second. As I told you before, we say 90 times 1000 divided by 3600. Two zeros cancel, and we do the needful, which if you use your calculator should give you 25 meters per second. You can either write it as m over s or ms negative 1. This is in the index in the scientific notation or the index notation. So we can move to the next slide as well. So we are looking at another terminology, non-uniform velocity. Non-uniform velocity. So this is where the velocity in which the rate of change of displacement with time is not constant. Of course, this we are just adding the word not constant, because the other one was the constant rate of change of displacement. So this is the non-constant rate of change of displacement. The non-constant rate of change of displacement, as simple as that. So we move to another important aspect, which is acceleration. Now we have had people talk about acceleration, accelerating a vehicle, accelerating a bike, accelerating so many other bodies. So acceleration is simply the rate of change of velocity with time. You can add it or you can stop at that. The most important word is rate of change of velocity. Very important. This word is very important. And the unit is meters per second. Remember, the unit of velocity is meters per second. Divide by time, because acceleration is change in velocity, divided by time. It is here. It is captured there. So velocity is meters per second divided by an s, divided by a second. When you do the mathematics, this results to ms negative 2. This negative 1, when this s goes up using the laws of indices, this one goes up there. So negative 1 minus 1 is negative 2, and eventually we end up with the negative 2. So that is our unit of velocity. Let's go to the next slide. We have an example here that is going to help us to find acceleration. A car from rest moves to a velocity of 20 meters per second in 4 seconds, and the question says find its acceleration. So we have already said that acceleration is change in velocity divided by time. Are we together? Change in velocity divided by time. So acceleration is equal to final. So the formula is, what is this change in velocity? Change in velocity is final velocity, and final velocity is given by a letter v minus initial velocity. Initial velocity is given by a letter u divided by time. So we normally use the formula v minus u out of t, which will later give birth to the first equation of motion at a later time. So we are saying acceleration is equal to v minus u out of t. V is the final velocity. Now in the question, it accelerates from rest and moves to a velocity of 20 meters per second in 4 seconds. So this is the time, this is the v, and rest, it is starting from rest. So our initial velocity is 0 because it is starting from rest. So when I substitute there, I will have v, which is 20 meters per second, minus 0 divided by 4. The upper thing, the numerator, gives you 20 divided by 4, which is 5. So still our answer is 5 meters per square second. The unit is very paramount. That unit is very paramount. Acceleration is in meters per square second. Don't confuse those two units of velocity is in meters per second, while this one is in meters per square second. So we can move to our next slide and we'll look at more examples. Number 2 is here. A train has a speed of 72 kilometers per hour and its speed after 4 seconds is 144 kilometers per hour. Find its acceleration. So, like we've already looked at the previous number. It is important that we change these units of velocities because they're in kilometers per hour, kilometer per hour. The reason we are changing is because our time is in seconds, so you cannot deal with hour and then seconds simultaneously. No. So the first assignment for us, the first task for us is to convert 144 kilometers per hour. First of all, let us first put on table our initial velocity u, our final velocity v, and our time. Time is 4 seconds. Good. What is our initial velocity? That is correct. Our initial velocity is 72 kilometers per hour. What is our final velocity? That is correct. Our final velocity is 144 kilometers per hour. So after looking at that, we can now do the needful. How? Let's convert both of these speeds from kilometers per hour to meters per second by doing the needful. 144, we are first converting this. 144 times 100 divided by 3600. The mathematics gives you 40. Then we also do for initial, we get 20. Then we come and substitute. Then we do the substitution, and finally we get our answer there. And you score a very good mark if you can do it. So thank you those that have done it, and I've awarded you a very good. Okay, let's go to the next slide. So another question. A body is brought to rest from a speed of 90 kilometers per hour in 10 seconds. Find its acceleration. So again, acceleration is v minus u out of time. Together, class. Okay, that's good. So initial velocity is brought to rest. English, mark that word. But it is from a speed of 90 kilometers per hour in 10 seconds. So you must not rush. It is brought to rest, meaning that the final velocity is now 0. Perfect. Thank you. Then the initial velocity is now, that's correct. Thank you. The initial velocity now is 90 kilometers per hour. Then the time is 10 seconds. I don't know whether you can see that. Okay, that's good. So, but again, this is in seconds and this is in kilometers per hour. So what do we do, class? That's correct. We are going to convert 90 kilometers per hour to meters per, we are converting this to meters per second. Correct. We do the usual mathematics. The usual mathematics is what we are doing. So we have 90 times 1000 over this one, that is fine, you get 25. So the formula of acceleration is change in velocity divided by time, or final velocity minus initial velocity divided by time. Final is 0, initial we have just done it here, initial we have just done it now, it is there, 25, it is there as 25. So we move on. So it is 0 minus 25, 0 minus 25 divided by 10, of which that is negative 25 divided by 10, which is negative 2.5, of course, meters per square second, and you score all your marks. So that's what we need to look at that point. Score all your marks very comfortably. So this marks the end of our tutorial, and hope you have learned something about motion and the terms. I want to remind you of those terms. The terms you must remember: speed, how to define speed, how to define velocity, and the differences between these two. And you also go to distance. I'm trying to look for the pairs that move hand in hand, distance and displacement. These two move hand in hand. This is scalar, this is vector, and from that you need to go to acceleration that we have just looked at. Then the other words are uniform something, uniform velocity, uniform speed, uniform acceleration, uniform this. Whenever they talk of uniform, just ensure that you attach the word constant in your definition. The other words remain the same. Now I'm giving you a simple assignment to go and research. So the research I'm giving you is to go and look for the definition, of deceleration. Deceleration. I want you to go and look for that, and look for this. I want you to look for the definition of deceleration, and that marks the end of our tutorial. Bye bye, see you in the next tutorial. Have a nice time.